On what lesson? A and 12. Okay, what else? Anybody have a question about something on 87? No? 87 was good?
I have a question about 86.
Okay.
Find even number? What is that 2x or something else?
All right, hang on, I'll get to it. What else? I know there were more on 88.
17 on 87.
17.
Yeah.
Okay. Anything else on 88?
No. Oh, I had 17 on 88 as well, actually.
Okay.
Wow, I thought it was your favorite one. I know.
All right. So let's make this a productive time so we can get to our other two lessons. We're not learning anything else after today, so Monday will just be review.
Wait, we're not learning anything else, like period?
No, just before the test next week. All right, 87, 17.
Can you go for 17 as well on 87?
I have it. I got them.
We got different.
Okay, so 87, 17, they want us to graph y equals negative 3x plus 2. We have talked about this a bit. I've went a little bit further than you guys need to know for this class, but I want to help start priming your minds for next year. Nonetheless, what you will be expected to be able to do on your test is take an equation such as this, make a table, get points from your table, and simply plot the points on a graph and connect them. Okay?
I have to make the table. I never make it.
The table is like a stepping stone. Eventually, you'll bypass the table altogether because you're going to learn about the patterns that are contained in this equation.
I don't even like the table.
All right. Anyways, that's what we're doing now. Okay, and again, it is a stepping stone, and they tell you let x be negative 1, 0, and 1. So again, these are, we talked about this Tuesday with focus group, these are inputs. What do you do with inputs?
You input them.
Put them in order to get
An output.
Yeah, so the input goes in for the x. So let me do this. I'm going to take it one step further. I'm going to make this y equals negative 3x plus 2. So what I'm going to do, I'm going to plug it in here. So negative 3 times negative 1 plus 2. So you see how I input the x value right there according to what it says I'm supposed to do here in the rule. So that's going to be a positive 3 plus 2. That's 5. So I get the point, negative 1, 5. That is up in quadrant 2 for anybody paying attention there.
How did x get negative 1 and 0 and 1? Did it say in the book?
Yes.
Okay.
It tells you, it gives you those. I will not give you those on the test. You may simply pick any 3 values you want. You only technically need 2, but let's do 3 for now. Okay, 0. So negative 3, 0, plus 2. Multiplied, we're going to get 0 here, plus 2, that's 2. Okay, so again, there's the x value. Here it is being input into the rule. That is the output. So 0, 2. 0, 2. Last one. So negative 3 times 1 plus 2. That's going to be negative 1. So I plugged in 1, I got negative 1.
I thought we did the opposite of the numbers. Like negative 1 would be 1.
No, that was a particular rule that we did on Tuesday. So you always just do what the rule tells you to. So that negative 3 is just going to multiply whatever you put.
That shows you what.
Yeah.
So it's just a formula each time.
It's a formula. I don't like saying that word because people are like, it's just a formula, I don't remember it. But some people they really understand what I mean by formula in that it tells you what to do to produce something. Okay? So if you're like Finley and you don't have like a bad opinion of the word formula, then use that to help you understand that that's all I've meant earlier by relationship or rule. Rules tell you what to do. And in Algebra 1, these are going to be called function rules because they tell you what to do with the input to produce an output. Cool? Okay. So we'll connect the lines, or dots, to make a line. We'll put arrows on the end of both to illustrate that it continues forever in both directions. Having said that, I hope you understand that means there's an infinite number of points on that line.
Yep.
We simply put 3. But hopefully I'm communicating to you that The benefit of understanding this type of representation is that it's way simpler than simply listing all the points. Okay? So that's one of the best ways to think about why. Why do we have to learn this? It is a way to represent the relationship. And the graph is just a picture of it. Okay? The graph is just a picture of it. So, I think one or two people were asking about, hey, what about a graphing calculator? What if I got one of those? I don't think you need to buy one of those yet. I would wait to see what high school says. Desmos is what a lot of the public schools are using now because it's free.
That's what I used
Okay.
for a while before.
But here's what we're going to do. We're going to test negative 3x plus 2. And you should be able to see the same points on there. There's 0, 2. But you see how it's a picture of the it's a picture of the equation. That's what a graph is. It helps you see the relationship, and then you can see geometric patterns. You can see rates of change next year. Okay?
We did that before.
Yeah, yeah. All right, so that's 8717. So then we have 88A. So surface area. So this was kind of a pentagon-like shape. Almost kind of like a house. Autumn, I think yours is better than mine. All right, but here's what we got. 4, 4, 4, and then these were 3. So what we're supposed to do, and we didn't talk a lot about lateral surface area, but again, the lateral surface area is just the area of the sides. So not the top and bottom. Not those house-shaped things, but rather 1, 2, 3, 4, 5 rectangles. The formula given in your book for the lateral surface area is actually even simpler. The lateral surface area is the perimeter of the base times the height. So let's find the perimeter of the base. The perimeter of the base equals 4 plus 4 plus 4 plus 3 plus 3. 18? And then they told us that the height, it is a 40 meters tall. So 18, so I could say lateral surface area
Can you move the camera down?
equals, oops, sorry. I can actually make it maximized too, sorry. No, I can't. Let me pause and say, seriously, why? Okay, that's better, right? All right, so that now you can see. Sorry, Quentin. Thanks for that. So it's going to be perimeter of the base times the height. 18 times 40, or was that 720? 720 meters squared. So because it's area, it's going to be meters squared. Again, we're saying meters times meters. So the other way to do that, guys, would have been to find the area of each individual face on the side, right? So that one would be 4 times 10. And so would this one. And this one would be 3 times 10. So what I'd have is 3, 4 times 10. Right? 4 times 10. Am I getting that right? 4 times...
No, it'd be 40, right? 40 minutes.
I'm sorry, 40. Where did I get 10 from?
Oh.
There, that's much better. 4 times 40, and then we have 3 faces just like that. And then I have 2 faces that would be 3 times 40. So 2 faces that would be 3 times 40. Okay? So 4 times 40, that's 160. 3 times 160 plus 3 times 40 is 120. 2 times 120. And hopefully, that's 720.
Yeah, hopefully.
So 480 plus 240. What do I mean, hopefully? Well, I'm going to confess something. I don't just look at answer keys. I do the math on the spot with classes, and I make a mistake sometimes, right?
I definitely don't do answers.
Right. So, lateral surface area. Now, look, if you remember the formula, that was way faster, right? But hopefully, I don't want you to depend on your memory because a lot of times it fails us. but if we practice, we can depend on it more. Nonetheless, lateral surface area, if you remember the definition, it's just the sides. The area of the sides or faces. So if you can find the area of each face on the side, you just add it up together. Okay? 8812. All right, another problem. So this was like the problem from class on Monday.
This is the one in class.
Yeah.
Oh, yeah. Okay, so again, we're asked to find the lateral surface area. So here's one face. Let me go ahead and give you the dimensions. I'm sorry. 6. And this was a semicircle with a radius of 2. And then this was 6 also here. And 7 centimeters tall. How far is this side? It doesn't say in the book.
It would be the diameter times 2.
Not diameter times 2. It would be the diameter. The radius times 2. Since the radius is 2, you're right, it would be 4. So I can find the area of this face. Well, that would be 7 times 4. Plus the area of that shape that wraps around. Can anybody tell me what shape that would be if it was uncurved? A rectangle with a height of 7. But what would be the length? How far out would it stretch if I unfolded it?
A little box.
What would be 6 plus 6 plus this curved section? Oh no, what is that?
That's 2. It's a pi.
That's a half a circle, so I'd be finding half the circumference. I would use pi times 2 because 2 is the
3.14.
radius.
2 pi.
So we could say 2 pi. Now think about this, guys. The entire circle would have been 2 pi times 2, or 4 pi. But since the radius is 2, I can say the circumference over 2 equals 2 pi r over 2. Right, those would cancel. And so I would just have pi times the radius. So it would be 2 times the radius. I'm sorry, 2 times pi. So we've got 28 plus. So that's going to be 12. 7 times 12 plus 2 pi. You guys probably aren't going to like that I leave this in terms of pi, are you?
I like pi.
Me too.
Yeah, I got it.
So let's see, 104, 112 plus 14 pi.
I think that's what I got.
So some of you want to get that was an even problem, so the answer is not in the book. Yay! Okay, so I have 112, no, I'm sorry, let me just do this. 14 times, where's my pi button? Plus 112. 155.98. And that has centimeters squared.
Can you say that answer?
155.98. Anybody else need
I
that?
need that.
Okay, pass it back to the table diagonal to you after that. If they need it. Okay, actually, I don't know what problem to do next. 12, 6, and 17.
I don't know, but I got
You're the 12.
That was number 87.
got
Lesson 87. So lesson 80. Oh, did I? Okay, I'm sorry. Already did 6?
No.
Did somebody need me to do 6?
I just wanted to know the answer.
Ah, okay. So, number 6, A, it says an even number. That will be 2x. That will always be even. Well, 5 times 5? Huh? Okay, we'll get... Wait, what opposite thing? That's not on this number, is it? We'll get to that in a sec, I hope. The next even number.
2x plus 2.
2x plus 2? Ah, you see what Quentin did there? If this is automatically even, then even numbers are 2 apart. What is not stated here is that x has to be an integer, a whole number. If we're doing decimals, then this goes completely out the window. So for both of these, x is an integer or whole number. Okay? If I can write it. For both of those. Yeah, 3/2 of a number. Well, that sounds really easy. 3/2 x, and then d, the sum of 3/2 of a number and 6. 3/2 x plus 6. Now, A and B were much harder than C and D. Huh? X plus x for what? Yes. But we're going to learn to combine those after spring break. Okay. Yeah! 17. 17 is another line. 17 is another line. Y equals negative 3x minus 1. So, here's the thing. Negative 1 is that point. Go up 302, down 301. And that's what it looks like. I'm going to label those points for you. Negative 1, 2, 0, negative 1, and 1, negative 4. Okay, I skipped the table because I know the rules and the patterns and the stuff you're going to learn next year. But it did ask you, negative 2. So I put one more point up here. That'd be negative 2, 5. Okay. And again, all we do is make the table and plug in those inputs. Okay. 89. So, somebody need this paper?
Me. Here's this paper.
Anybody need the former paper?
I keep this.
Here you go. So, let me go back just for a moment. 89 and 90. So, 90 is algebraic sentences, and we're just going to add one thing to algebraic phrases. But before we do that, I kind of already taught lesson 89 without meaning to. The trichotomy axiom sounds really complicated, but basically, you have 3 choices for a number. A number relationship. That's all right. So you have your 3 options, okay? One number is greater than the other, one number is equal to the number, or it is less than the number, okay? So I'm not going to write those definitions, the words out. These are the symbols we're going to be using, okay? But anytime you choose one of these options, listen to this, the other 2 go away. Okay? You hear that? If you choose one of these options, the other 2 go away.
Yeah, because that one option is right.
Okay, so think about this in a really common sense context. If you are older than your sister, you are not equal to your sister's age, and you are not younger. So by being one condition, it rules out the other 2. That is what is meant by axiom. It's like a law, a mathematical law. Okay? Luke, you all right down there? Okay. But hopefully you've seen that we could actually state 2 conditions with an or. So, if I say something like this, if I say that x is less than or equal to 3, then what can I say x must not be?
X cannot be less than or greater than 3.
X cannot be greater than 3. Okay, so again, I used these 2 conditions to say that x was not 3. And I know you're like,
3 dots.
huh? Therefore.
Therefore.
I forgot. You weren't there for that.
Finley.
Okay, so let me make another one. Let's say we say that y is greater than 4. Therefore, what can I say must not be true?
Y is not less than 4.
It's not less than 4, and it's not
Equal to 4.
okay. So I have one more.
Why?
z is not equal to 0.
Yep.
Therefore,
It's
Either
greater
greater
than or
than or
less
less
than.
than.
That's simple.
that was an easy one. Now you might think, this is weird. Somebody said this is simple. Somebody said this is crazy. This is actually a very foundational concept for anybody who wants to go into
Math.
computer programming.
No.
It's not as bad as it sounds.
Do you go into computer programming?
I had taken a class or two because I was interested in pursuing that as a job a few years ago.
Well, then why didn't you? Do you want to get math teacher instead?
I had a third kid. I got too busy. So, I don't know. It might still happen. We'll see. It's a great career to go into. Right now, there's a huge shortage of computer scientists. And so a lot of jobs will, yeah, I would say that too. A lot of jobs will actually hire you and train you if you have just an inkling of ability.
Well, I won't.
So, don't be so hard on yourself. You never know.
I don't even have any.
Okay? You guys are only 12, 13, maybe 14. But
I am not.
I gave you a range, okay? All right, anyways. Does this make sense?
Yeah.
I'm older than you by like 2 years. I'm 13. I'm older than you. I'm 13. I'm older than you.
All right, so let me give you a couple other examples. And instead of writing some conclusions, what I want you to do is give me a true or false. Okay? -4 is not less than 10. True or false?
True. True.
I heard one false and two trues.
-4 is less, so it's false.
That is false.
No. Okay. I don't. I'm still writing it. Wait, so it's
Why is there a
-4 is
line
not
in the middle?
greater than
That means
10.
not.
False. That's what
True.
false.
2 is not greater than 0.
False.
That's false because
2 is greater than.
2 is greater than 0.
True. Whoa. True. False. True.
False.
True.
I didn't even read it. I just.
You just said the other one because I didn't tell Luke he was right. Luke is correct. It is true.
Aha, I was right.
Now, again, the context or the condition lies in the or. It says less than or equal to. So if it meets either one, it's true. Okay?
False.
I'm done with that one, guys. Okay? Last one. Let's see. 7.
Oh. Those are gonna be on the
It's false.
It's true.
False.
It's true. It's true. It's true.
It's true because
It's true. It's equal. It's equal.
7 is equal to the square root of 49, which is 7.
True.
So,
Times 7 equals 47.
all right.
No, it doesn't.
That's it. Actually, I have one more example for us because there's some number lines involved, okay? So I want you to graph this. Graph x is not less than -1. So we've got to figure out, okay, well, what can x be if it's not? Okay, so one strategy here is, okay, shh, guys, let me talk. Given this one, given the limitation, we can then write, okay, what is it allowed to be?
Greater than or equal to.
Okay, so we'll do a little therefore. X is greater than or equal to -1. So how do we graph that?
What do you draw a number line and you put all the numbers
Colored
on
in
there.
dot. And
Colored in dot, shaded to the
right.
where all the numbers that are bigger than -1 exist. Okay. Now, do you see how I only did the number that was in the discussion? You don't have to do all the other numbers.
Why not? I like to know the other.
All right, you can waste that time if you want, but you only need the number that matters in this problem. Okay. If you want to put 0 to help you, that's okay.
You know my trick. I never looked.
The number line matches the symbol.
It does. As long as the variable is written first. All right, so that's lesson 89. That's it. Okay, so those are logical conclusions. Anybody need this? Okay. So lesson 90, we've already done this. We've already done a lot of this. I didn't get to practice as much, and we might have to save this quizzes for Monday. It's just practice. But lesson 90, algebraic sentences, okay? I like to call them statements. Okay, so can you make a statement about the weather today?
No.
Rain.
It's a 90% chance.
No, all right, so that would be an incomplete sentence, right? Make a complete sentence or statement about the weather today.
The weather is
The weather is quite
The weather is cloudy.
weather.
All right, stop there. Let's go with that.
weather.
Okay, the weather is cloudy. Okay? So we start with Tristan's. Tristan would be just an expression, right? It's something, right? It's rain, but it's not telling me anything about it. It's not making a statement. So rain would be like an expression. We could say an expression doesn't have a complete statement or thought. So x plus 3, 5 times y, z, half of z. Okay? But where we make the jump to a sentence is where we're going to call it an equation. And the only difference is that it has an equal sign and something is equal to it. So we can say x plus 3 equals 11. 5 times y equals 25. Z divided by 2 equals 7. Okay? So I want you to pay attention to the difference. An algebraic sentence or statement is an equation with an equal sign. Therefore, what can we do with these that we cannot do with these?
Solve it.
We can solve these. Each of these has one unique solution that makes it true or satisfies the equation. So, what we did earlier in the week or last week was we were given a sentence, or rather a collection of words, and we were supposed to write an algebraic phrase with that. So, 5 increased by a number. So we talked about some clue words. Increased meant, sorry I didn't write the C there. Increased meant add, right? So check it out. 5 increased by a number. All right, that's not so bad. And then a number, well, that's awfully vague. Why do you think they do that? Because it's unknown. But the only jump we're going to make today from there is 11. So I spot an is. That means I'm going to have an equal sign. And then we're saying, okay, that is or that produces 11. And then the last step would be, yeah, let's solve for these. Okay, but before we do that, don't pack up yet. I got 5 minutes left. I don't know what y'all are doing. Probably listening to all this racket out here. Okay, so this was last week. 5 increased by a number. Get the expression. Now, if it's a sentence or an equation, we're going to solve it to find the unique solution. Okay, so how do we do that in this problem, Autumn? All right, so we need to subtract 5 on both sides. I know most of you are like, it's 6. But I want to make sure you have all of those skills. So I have n equals 11 minus 5 is?
Is 11 minus 5 is 6.
Yeah, so I can plug it in and check it, right? Let's make it a little more interesting. Half the sum of a number and 1 is 41. Okay? All right, so I made this much more interesting really quickly, okay? So let's think about the operations that have to take place. Half, what does that mean I'm going to do?
Divide.
I'm going to divide by 2. Sum, what does that mean?
Plus.
I'm going to add. Of. Okay, maybe that's not right because I said sum of a number. Ignore that. The sum of a number and 1. Okay, so I'm actually going to leave all of that in pink. Okay. Is. I like where Quentin's head's at. And then we have the 41. That's the easy part, right? That's the output. So let's go ahead and do that first. And what we learned Monday was that I can write 41 equals, or I can write something equals 41. The order does not matter when I state the same thing. So I can put all of this equals 41 if I want to keep it in line with my sentence. Now here's the hard part. There's two operations going on here, and if you get the order wrong, your answer will be wrong. Now, Quentin, you said I should use something here. All right. Why do I need parentheses on this problem?
Because you need to add before you do the division.
Okay. That seems kind of backwards for order of operations, but the statement says half the sum. So I'm taking half of the sum, which means I have to find the sum before I can take half of it. All right, so parentheses, what am I going to put in parentheses?
X plus 1.
X plus 1. Okay, so there's the sum of a number and 1. And then how do I take half of it?
Over 2.
We can put divide by 2, but Quentin's he's moving forward because you heard me say the division symbol's going away soon. Some of you don't seem happy about that. But division looks like a fraction. It is a fraction. So we could put divide by 2 like that, but I think you should take Quentin's advice and write it this way. Over 2 equals 41. Like that. Okay? So I'm taking half, whether I write divide by 2 or I just put everything over 2. The most important part for you to get for this problem, though, is you got to use parentheses to put an order of operations that is necessary to what the problem states. Now, if you wrote it like this, technically you don't need the parentheses in this version of it. You could just write x plus 1 over 2, but it's helpful nonetheless to understand why it's there. Now, how do I solve this?
You got to add 2 on...
I don't add 2. Nope, don't do that.
You
Don't do that either.
41 by 2 or subtract 1.
I do what with the 2, Quentin?
You multiply.
I multiply. How'd you know that?
Because it's the opposite of division.
It's the opposite of the dividing by 2. Catch that? So I'll stick a 2 up here, throw a parentheses around that, stick a 2 up here, throw a parentheses around that. Those 2's will cancel. That's why Quentin said to do that. I have x plus 1 equals 82, because 41 times 2 is 82.
Now subtract the 1.
Subtract the 1. X equals 81. So I gave you 2 examples. One really easy, one not as easy. Your homework will mostly be between that. I don't think you'll have one this difficult on homework. There won't be one there may be one like that on your test that's extra credit. Okay? But focus on the less thans. Don't get that order wrong. Be careful there and bring your questions on Monday for our test review. Okay?
I can use it at Walmart.
Bye guys. Great job, Quentin.